Hi there, it's Professor Monte again, and let's look at an exponential growth word problem or application. Okay, we're going to be using the formula P of t equals P sub 0 e to the kt, where P of t, remember, that's just a single number. That's not P times t, it's the population times t, is equal to P sub 0, which is the initial population, times e, that 2.7 irrational number, raised to the kt. K is the growth rate, constant of growth, and t is the time. All right, we're going to use that. Well, we've got this problem. It says in 2015, the population of a small town was 1,800, but by 2022, the population was 2,300. Assuming an exponential growth, let's A, find the population function. We'll stop there and we'll do that one first. So for part A, well, we're going to use our formula, P of t equals P sub 0 e to the kt. Now, here's what we know. So let's see. P sub 0, that's our initial population. Well, the initial population was the 1,800. We just plug that right in. Well, but I also know in 2022, the population was 2,300. Well, at the time, let's see, from 2022 minus we started in 2015. Okay, that's 7 years. So the population in 7 years, I still don't know K, but I know the time in 7 years was the new population 2,300. So that's what I do. My starting population, in 7 years, my ending population. I can use that to find K. I'll find that to 3 decimal places. But let's solve that for K. So I'm going to divide both sides by 1,800. E to the 7K. Now, I'm going to put this into my calculator. I'm going to write an approximate number up, but I'm going to leave the entire number in my calculator because I don't want that to be a rounded number yet. I don't want to round until I get to K. So I get 2,300 divided by 1,800, and it's about 1.2, it's actually 7 repeating. I'll go 7, 7, 8. But again, I'm leaving that whole thing in my calculator. I'm not rounding it in my calculator. I need to solve this. Remember, to solve that, I take the ln of both sides. We do that in another color pen just to save some room on the board. To get rid of the e, I'm going to take the ln of both sides. ln and e cancel out. They're inverse functions. I just get 7k. So I have 7k is equal to ln of this 1.27778 number. Divide both sides by 7. Now I'll really round it off. So this whole thing's in my calculator. I'm going to go ln of my last answer. Enter. And then, so now I have 0.245122 stuff. I'm going to divide that by 7. And I get a growth rate 0.035 if I round to 3 decimal places. So that's where I'm going to round. I may have some rounding errors, but I'm to 3 decimal places for my growth rate. So my formula, again, it's this P of t equals P sub 0 e to the kt. Well, P of t, that's what I'm looking for. That's the formula. P sub 0 was my starting number, 1,800. K, I just found out was 0.035. And then t, I don't know. That's t. That's my formula. That's my formula to find this population at any time. Okay, so that's my starting number. That's my growth rate. That's the way it always works. All right, so let's look through. Let's answer part B, which says estimate the population in 2040. All right, so for B in 2040, well, my time, 2040 minus I started in 2015. So it's at 25 years. So in other words, estimate the population in 25 years. Well, that's P of 25. Again, that's just my population in 25 years. It's not times 25. I'm not going to divide by 25 at the end. It's just 1,800 e to the 0.035 times 25. And remember to put that in parentheses if you need to. And I get my population 25 years later, or in 2040. Now it's just a calculator problem. I say, 1,800 times e to the power 0.035 times 25. Again, make sure that's in parentheses if you need to. Rounded to the nearest whole person, 4,318. I had 4,317.9755, and it's just an approximation, so I'm just going to round to the nearest. All right, so that's how many people I think I have. That's my estimate in 2040. Now I can go to C, which says, in what year will the population double from 1800? So let's see. In what year will it double? Well, again, go to my formula. P of t equals, well, I have 1800 e to the 0.035t. Now, this number is doubled, so it's twice or double what it started at. All right, so now I have to solve that, get rid of the 1800, and notice it didn't matter what it started at. Anytime we do this, I'm always just going to get a 2 over on this side if we're doubling. And so I've isolated my exponential. I'm going to take the ln of both sides. Remember, ln cancels out e. Those are inverses of each other. I just get the exponent. So I get ln of 2 equals 0.035t. I can divide both sides by that coefficient. And I get time as approximately, well, let's find number of years here. ln of 2, close parentheses, divided by 0.035, and I get about 19.8, we'll say about 20 years. Because we're just approximating this anyway. I don't know when in the year 2015 was at the beginning of the year, the end of the year, I don't know, so I'm just going to round that to the nearest year. So it's 20 years after 2015, so I'm going to go 2015 plus 20 more years, it'll be about the year 2035. All right, so that's how these problems work. There's a bit going on. Sometimes they'll only ask you for the function. Sometimes they'll ask you doubling time, or sometimes they'll ask you, how to use this to, sometimes they'll use all three, and you've got a lot of stuff going on. So anyway, there's an example. Practice these. The more you practice them, the better you'll get. The more you'll understand, the quicker they'll become, and the more apt you are to get a perfect score on your test.